You hear about it everywhere, right? Artificial intelligence this, AI that. But then you also hear all these other terms getting thrown around: machine learning, deep learning, and the big one lately, generative AI. It's like an alphabet soup of tech, and honestly, it can get super confusing. Are they all the same thing? How do they actually relate to each other?
Well, that's exactly what we're going to tackle right now. We are going to break down how all these technologies fit together, and we'll start with the biggest, most all-encompassing idea of them all: artificial intelligence. All right, so let's get into it. The best way to understand the relationship between all these terms is to think of it like zooming in on a map. We're going to start with the widest possible view, the entire universe of this tech, and then we'll get more and more specific with each layer. So let's start with that big picture. So, artificial intelligence, or AI, is the whole grand idea. It's the big umbrella. It's the broad scientific field that's been dedicated to a single, massive goal for decades: trying to simulate human intelligence in a machine. And we're not just talking about doing math really fast. We're talking about the ability to learn, to infer, and to reason, all the things we usually associate with our own minds. And this whole idea, it's not new, not at all. It really got its start as a research project way back in the 60s and 70s. By the 80s and 90s, it kind of hit a critical mass with something called expert systems. But for a long, long time, this was a pretty niche academic field. Until, that is, a brand new approach started getting traction and changed absolutely everything. And that's what brings us to our first real zoom in, the approach that truly changed the game. Let's focus on a specific subset of AI: machine learning.
Machine learning, or ML, it's pretty much exactly what it sounds like. We're getting the machine to learn. Now, the crucial point here is that instead of a human programmer sitting down and writing code for every single rule and possibility, we give the machine a boatload of data and let it figure out the patterns and make predictions all on its own. Okay, but how does that actually work? I mean, how can a machine look at a bunch of information and learn from it? Well, let's break it down with a super simple example. Imagine you show a machine this sequence. After seeing a square, then a circle, then a square, then a circle. What do you think it's going to predict comes next? A square, right? Of course. And the more data you feed it, the more squares and circles it sees in this pattern, the more and more confident it becomes in that prediction. But, and this is where it gets really interesting, what if, smack in the middle of that super predictable pattern, you throw it a total curveball, like a triangle? See, a machine learning algorithm isn't just good at predicting what comes next, it's also incredibly good at spotting what doesn't belong. And that simple idea, spotting the outlier, it's a real-world superpower. Think about cybersecurity. Experts are constantly looking for weird behavior, users doing things they aren't supposed to. Machine learning is what helps them find that one triangle in a vast sea of normal square and circle activity, flagging a potential threat that a human being could easily miss. Okay, so let's zoom in one level deeper. Inside the world of machine learning, there's an even more specialized and, frankly, more powerful technique. This is our second layer: deep learning. So, deep learning takes all the ideas of machine learning and kicks them up a notch using something called neural networks. These are incredibly complex systems that are literally designed to work a bit like our own brains. And the reason it's called deep is because it uses many, many layers of these networks, which allows it to spot far more complex and subtle patterns in data than regular machine learning ever could. This quote here really gets at something fascinating about it. Because deep learning mimics the brain, it can sometimes feel like a black box. We know the data we put in, and we see the amazing, almost magical results that come out. But the why behind its conclusion can be a total mystery. With all those complex, deep layers, we can't always trace the exact path of logic it used. This makes it incredibly powerful, but also, a little unpredictable. And that really matters in fields like medical diagnostics or self-driving cars, where understanding the why behind a decision isn't just a nice to have, it's a need to have. And this brings us to the absolute center of it all, the very core of our zoom in. This is the tech that has caused the massive explosion of interest we've all been seeing. Built right on top of that deep learning foundation, we have generative AI. The keyword, the absolute game changer here, is generative. While all the AI we've talked about so far is fantastic at analyzing information that already exists, generative AI, or Gen I, creates something brand new. It all runs on these things called foundation models, and honestly, these are the engines driving this whole revolution. Just think of them as massive, massive neural networks trained on a stunning amount of the internet: text, images, code, you name it.
which gives them a broad, foundational understanding of our world that they can then use as a springboard for creation.
So you've probably heard this, right? The argument that Gen I isn't truly creating anything, that it's just remixing or regurgitating stuff it's already seen. But let's think about it this way. Every note in music already exists. There are only so many. Does that mean any new song is just a regurgitation? Of course not. A great composer uses those existing notes to create something totally new and beautiful. In a very similar way, Gen I uses existing data to generate novel content.
And the stuff it can create, it's kind of mind-blowing. All the chatbots we're using are powered by large language models that generate text. It can generate audio, perfectly recreating human voices. And of course, it can generate video, which is how we get things like deepfakes. The point is, it's not just analyzing, it's actively producing.
Okay, so let's pull the camera back out for a second. Why does any of this matter right now? Why is it such a big deal? Because this final layer, generative AI, has completely changed the landscape and has blasted AI into the mainstream like nothing before it. I mean, if you look at the adoption of this technology over the years, it was a pretty slow burn. Early AI was mostly stuck in research labs. Then, machine and deep learning came along, and we started to see some real-world use. But when generative AI and its foundation models hit the scene, man, adoption went straight to the moon. This is the reason AI suddenly seems like it's everywhere, all at once. So, to wrap it all up, the best way to think about it is like a family tree, or maybe a set of those nesting dolls. Artificial intelligence is the big, overarching idea. Machine learning is a specific way to do AI. Deep learning is an even more advanced technique within machine learning. And finally, generative AI is this powerful evolution that uses all of that deep learning to not just understand our world, but to create new things within it. So we've figured out the what. We know how all the pieces fit together. But that just leaves us with a much, much bigger question to chew on for the future. What's it truly going to mean for all of us when AI can not only understand our world, but can start to actively generate pieces of our reality?